our next session is going to be a tech showcase. It's grid connection reform, securing and optimizing power connections. We've got Brian Moorhead here today from eSmart Networks, who's going to talk to you for the next 20 minutes or so. And then we'll come back and we'll do a Q&A. We'll have some roaming mic in the audience. So please ask your question to Brian after his talk. Thank you.
So yeah, I'm Brian Moorhead, Grid Consultancy Director with eSmart Networks. And just a very brief intro before I get into the talk, just to set the scene in the context. So eSmart Networks were a UK-wide ICP and grid consultancy services, design and deliver grid connections, as well as offer upfront support in terms of obtaining and securing power connections in the UK. And we also work closely with our sister company, who is an Ofgem regulated independent DNO as well. And if you find today's talk interesting, we do publish a free podcast to try and keep people up to date with all things grid connections in the UK. So my talk today is a game of two halves. The first half will be going through connection reform, which is the hot topic on everybody's lips if you're trying to secure power for new data center developments in the UK. And then we'll go into, well, what does that mean for developers and investors in data centers in the UK at the minute, and how can you navigate the ever-changing process of getting grid? So just to kick off then with a bit of a quick recap on where we're at and where we're going with electrification in the UK. So these graphs are from the UK's sixth carbon budget, which is kind of the closest thing we have to a decarbonisation strategy. And as you can see, both buildings and surface transport are forecast to pretty much wholesale transition to electrification. So the kind of demand for electrification is really, really growing and heating up. And we're seeing that at the minute, like everybody is electrifying. So obviously everybody's fully aware of the growth in AI and data centers and the power requirements. But it's not the only sector that's got a huge demand for grid capacity. Another big one at the minute is battery storage, and we'll put some numbers to it on the next slide. But we're also seeing it at an industry level. So people who would have been bringing in gas connections to new industry are also electrifying factories. We're also seeing it at the heat level as well, new domestic premises, electrified heating, and then public transport, rail and bus, as well as EV charging. So there's huge demand for electrification and grid capacity right across the UK. Just a couple of quotes then. So Elon reckons that AI is going to run out of electricity in transformers next year. I think that's a little bit pessimistic, but it's not just the UK seeing the problem, I suppose. And then the CEO of our national grid is basically comparing the current grid today as if we're in the 1950s and you can't take electricity for granted. So that's another pretty stark comment as well. But it's not all doom and gloom though. I think we need to pick into the stats and actually see what's going on. So I'm going to throw up some numbers to try and illustrate where we're at with our grid today in the UK. And I know everybody's not an electrical engineer in the audience, so I will just explain. I'm going to be talking a lot about gigawatts. Just to kind of set some context, what is a gigawatt? It's 1,000 megawatts, or you need 1.21 gigawatts to time travel in a DeLorean. Just a little Easter egg for any Back to the Future fans. A bit more context then. The lowest summer demand in the UK is about 14 gigawatts. And the peak winter demand is about 44 gigawatts. So that's just some context in terms of the GB grid. Then the big issue, really, the current queue for connections. So for demand off-takers, energy off-takers, there's 42 gigawatts in the queue to connect with accepted offers. So that's going to be data centers, large industry, EV charging, and another 234 gig of battery storage, which is just, ludicrous, really. And then if we look at a renewable export connection queue with accepted offers, it's well above 600 gig. So just to put this all into scale, you can basically see here, compared to our current peak demand, the queue for connections is really, really outrageous. So the yellow dashed line there is approximately the renewable capacity we need to hit net zero for 2050. The blue line is roughly how much battery storage we need for 2050. So you can just see there how the connection queue is just way, way, way above what is actually needed to decarbonize our electricity system. And that's the big issue, basically. Like the connection queue is as much a fantasy as time traveling in a DeLorean. Like it's just all not going to connect. It's not going to happen. And it's coming up the system. So we do a lot of power feasibility. We do a lot of network modeling. So like this is the nationwide queue, nationwide level. But if we step down to like a site-specific, looking at a local substation and a specific data center, what does this look like? And it's basically a similar picture. quite often when we look at different sites. So I think we spent some time with about 3 different clients yesterday looking at specific sites, specific substations, and it's a similar picture basically. There's a load of these zombie projects gumming up the queue that's taking up electricity bays to plug cables into and taking up import capacity, but they're not moving anywhere and they're not going anywhere. And often, like the large majority of these are battery storage or solar projects. Because that queue's so oversubscribed on export, they're sitting there with 2035 connection dates, so they've no impetus to move anywhere. So when you're coming along with a new data center development, you're often sat at the back of that queue. Like one of the examples yesterday, I think had 8 battery storage projects, about 400 megawatts ahead of it in the queue, but there was capacity available. So that is one thing. When you do look at the substations, the lines, the cables, and the wires, and model them out, there is capacity there. The big issue is a processing issue and a queuing issue of actually accessing that capacity. So that's why we need connection reform. We need to try and get projects that are viable to build and get them to the capacity that is there so that we can move forward and actually connect and get stuff built. So connection reform then, where are we at with it? So I think Rishi Sunak announced, I can't remember, back about a year and a half ago now, that the current process of first come, first serve and allowing all these speculative projects to book up capacity, we're going to move away from that to first ready, first connect. Now, we had the first detailed proposals out from National Grid earlier in the summer via consultation. And basically, it was a little bit of a damp squib, if you ask me. It was sort of moving from first come, first serve to kind of first come, first serve asterisks, where basically there had been talk of, trying to maybe use planning or find shovel-ready projects and promote them to the top of the queue. They've basically just said, well, we'll filter the queue based on land rights and we'll add in some milestones. So effectively, most of those zombie projects are still going to be allowed to sit there for another 2 to 3 years before anything really happens. So the one good thing is I think industry has kicked back quite a bit on sort of the softer touch approach that was consulted upon, and Ofgem and DESNZ have already tasked National Grid with coming back with a short list of options to cut the queue further. So they're going to look at additional financial hurdles and raising the financial bar to booking up capacity. And then they're also looking at additional technical hurdles as well. So that'll be looking at more of the system that you might, there's technical criteria that they would use in the Republic of Ireland, for example, in EirGrid, as part of their transmission system planning standards, to do with either the technical capacity on local parts of the network or the actual potential quotas for technology such as battery storage and solar that make more sense against 2050 targets. So we'll know more about those in late September, maybe early October. But yeah, I think the thing at the minute is we don't really know exactly what the rule set's going to be. There still is quite a lot of discussion around it. It's just keeping up to date is the key thing at the minute. A few other key highlights from the current connection reform proposals then. Basically, there's very little being done to unlock firm capacity that's been allocated to battery storage. This is one of the biggest issues I think that nobody's talking about, and it's one of the ones we come up against the most often when we're looking at capacity on the networks for new data center projects. Basically, the distribution network operators have given firm capacity to loads, there's a couple of 100 gigawatts in the queue there of battery storage. The battery storage systems do not need it. They're not going to import power at peak times when power is most expensive. It makes no sense for their business model, but those are the assumptions the network operators are running with. That means that blocks out that power capacity for data center developments and other power users that do actually need the power during peak periods. Distribution connections were left out of scope. That basically just leaves a big question mark over a substantial portion of the capacity queue, and the implementation timescales for connection reform have all been pushed back as well. So the initial timescales were to bring in is that still working? Yeah, still working, sorry. Was to bring in the new rule set by the end of the year and roughly speaking take about 9 months to then implement it, kick people out of the queue and get the new system up and running towards sort of Q3 next year. That's all been pushed back by about 3 to 4 months, just recently announced there the other week. And so basically you're looking at probably the end of next year, best case, before this really starts to cut into the queue and free up projects. And I wouldn't be surprised if it does get pushed back again. But again, we'll keep an eye on how things progress. There was another thing in there where National Grid were giving themselves powers to fast track certain projects. Again, this has caused quite a bit of consternation in the industry because it's a little bit vague and nobody's really sure what criteria they'll use or what projects they'll pick. And then the other big one at the minute is if you're looking at transmission level connections. So basically you're kind of roughly speaking, more than 100 megawatts, any new transmission connection applications have basically been put on hold until connection reform kicks in. So effectively, if you apply to National Grid now for transmission application, you'll get basically a budget offer that's not really worth the paper it's written on. And you effectively have to wait until connection reform kicks in. You could be waiting to the end of next year before you can actually get that firmed up. So that's the kind of current picture today. We, as I say, I'll plug the podcast again. We just released that for free, quick 15-minute update. We try and do it monthly just to keep people up to date if you're investing or developing data centers, just very high level on the key topics and where we're at. So that brings me to the second half of the presentation, and it's the so what. So, you're developing, you're investing in data centers today. Well, how do we get power to the data centers? What do we need to do? How do we navigate the increasingly complex environment that we find ourselves in? So we kind of explain it to our clients. We break it down. Effectively, you face 3 key hurdles to getting grid to your data center. The first one is you can't find the capacity you need within the timescale or the budget you need it. 2035 connection dates and all that kind of stuff that's become commonplace. The second hurdle you'll find is, will you get a connection offer from one of the network operators that looks good on the face of it, and it's just riddled with, we talk about the 10-year, the £10 million risks. Recently seen a connection offer with a £500 million security risk in it. So our £10 million risks are starting to get blown out of the water even now as well. And in the third big hurdle, you've got your offer, you've paid your money, you've got it secured, you think you've got power in the bank, and now the network companies are cancelling and rescinding capacity now more often and more stringently. So again, you need to watch out for that. So I'm going to take you through, we have sort of 3 high-level steps then to manage those risks and get past those hurdles. And I'm going to step into those in a little bit more detail on the next section. So starting with our grid feasibility, so we always recommend do your homework. So we look into the networks, we model out the networks, model capacity, and basically would tell our clients, here's all the areas, places you can get connected to the grid. Here's the capacity, the timescale, the key risks and the costs associated with each one. You can then have a conversation about, well, you might get 20 megawatts within 2 years. There might be 40, 50 megawatts then that's 5 years away. You can start to phase connections in, start to ramp up capacity, start to get a proper grid strategy together for a site. You can also identify if there's battery storage in the queue, who those people are. You can maybe, increasingly now we have clients that are looking at purchasing those projects to try and get up the queue as well. And basically part of the benefit of this is it speeds up the whole process. If you look at the network, you see what capacity is there. If you go to the network operator asking the right question for the right number of megawatts, or put your plan to them at the outset, you arrive at a viable connection offer much, much faster than doing the whole back and forth, asking for random numbers. They come back to you with an answer that takes too long, too costly, crosses third-party land. And then moving on to the next one, so you get your connection offer from a network company. There's probably 30 to 40 kind of common risks we see, and again, we internally talk about the 10-year, the £10 million risks. This could be a bullet point that says a protection study has been excluded. It could be a bullet point about a comms solution that means you need to run fiber optics between substations, or you need direct line of sight microwave links between 2 random substations that have nothing to do with your connection, and there's a mountain in the middle. So there's massive risks around basically the viability of a lot of these connection offers that network companies are issuing. So I should say, in my background, I used to work in a transmission company and a distribution company. I've been there, I've seen it. Some of these 50 million quid connection offers, it could be a graduate engineer that's got half an hour to get it out the door because they just have a regulated timescale and need to issue 1,000 of these a month. So they really don't have the time to properly look at it. So yeah, my one piece of advice, and we see it all too often, where people, they get an offer, it says 2028, it says 10 million quid, they think it's all good, only to realise far too late after they go and spend a lot of money acquiring a site, spending money on planning and everything else, that the actual date is more 2038 than 2028. So being aware of risk early is really, really key. I can't recommend it enough. I've seen too many people bitten really, really badly with this. And then thirdly is, once you actually have capacity secured, making sure you keep it. Don't let the DNO or the network company rescind it from you. They are getting more and more stringent on land rights planning and moving forward with the design of your substations. So if you look at at a minimum under connection reform, milestones are going to be a lot more aggressive. I expect it to move forward, become more aggressive again before it's actually implemented. But you really need to be on top of this stuff. And that brings us to actually optimizing connections then as well. So you've identified the risk at the due diligence stage. You need to get on top of optimizing those risks. So that's where we would work closely with our sister company in terms of you've got lots more technical flexibility in terms of shorter lead times for equipment, reducing land take of substations. Data center land's valuable. You want to minimize the land that's wasted, if you like, for the power infrastructure. And looking at innovative technical solutions and moving things forward towards those milestones as well, so you don't lose your capacity. So there's a lot of kind of site-specific examples I could kind of get into. Might be worth a discussion after if anybody wants to kind of run anything past me. So I did say I was going to keep it relatively brief. Just to wrap up then, in terms of 4 key takeaways, is consider your grid strategy. What, how, and who. What are you doing? How are you doing it? And who's doing it for you? Doing your homework. Really, really key. You can't negotiate or put a grid strategy in place with a network operator unless you've done the homework, you know the network, and you know what's possible. That's the only way to negotiate a proper solution that gets you away when you need it, getting phase plans in place and everything else. Due diligence, if I leave you with one message, please, please, please take grid due diligence seriously and do not take connection offers at face value. I'm sure there's plenty of people in the audience have already been bitten or found issues there. And then engaging the ICP and IDNO works early, and I can't recommend this enough. So we have a sister team in our company does the electrical and civil engineering design. The earlier they can get their hands on things, you can really cut time off lead times, off the overall energization timescales there as well. So yeah, that's basically me. We have a stand literally behind Laminar, just behind. Max is waving there, sitting in the stool. We're quite friendly. We're open to spending time with people. We can look at your sites. We've got the laptop here. Happy to have a chat at length after as well as take questions now. Thanks.
Thank you, Brian. Yes, we're going to take questions from the audience now. So we've got a mic roaming around if anyone's got a question.
Hi there. Thank you very much for that. Very interesting. So Bill Rees from Enso Energy. So I'm on the renewable and battery development side. And we have a number of connections, 132 and 400s from now for the next 10 years. And we're looking to build out solar and battery projects. But do you think there's opportunities and what's the best way for opportunities to partner on those connections? So you still build the solar and the battery, but also share those connections effectively?
Yeah, so good question, actually. So we are active in the battery and solar sector as well with customers there. And this is actually a hot topic. This is coming up every time we talk to the battery developers, every time we talk to data center developers, especially when we show them the queue of battery projects ahead of them. The first question is, well, hold on, can we like work with those guys? The big hurdle you come up against is typically your battery and solar connections are single circuit supplies, so they don't have the right redundancy and security of supply requirements for data centers. So basically where we start with those is doing a bit of an analysis on the network to look at, well, what would be the impact of upgrading that supply to, a more firm or more secure supply. The second hurdle you'll have is the network company, particularly at National Grid, are supposed to be modeling batteries differently. I don't think they've quite, the score. They haven't quite deployed their new CPAs, the planning assumptions. So there's a bit of actually negotiation to make sure they're, find out what way they've modeled it as well. So when they're trying to block your battery, they'll tell you they've modeled it the old way. When you're asking to team up with a data center, they'll tell you they're modeling it the new way. So they'll tell you whatever answer suits them. So there's negotiation to be had there as well. Those are probably the 2 key hurdles. The security of supply one is probably the main one we see at sort of face value that poses a difficulty, but it's all very site specific. You need to look at the grid in the area and kind of consider that. And it also considers as well, like I don't know if you're doing sites where you're bringing in 132 kV to get you up and running with an initial 50 meg and then the 400 is, so there's a bit of, well, again, could one of those solutions be doubled up for a data center or, that kind of thing as well. So, very specific. If you have specific examples you want to have a chat about after, definitely happy to look at them.
Thank you. Any other questions?
James Potter, Aperture Energy, similar background to the guy in front of me, sort of battery storage, renewable energy, various projects. Are you finding that a change from single circuit supply can be can be upgraded to sort of 2 circuits and effectively firm under sort of mod app or change to an existing project? Or are you finding that's an entirely new solution and therefore sort of effectively sitting at the back of a tech queue?
So the answer's a mix, basically. I'm trying to think percentage-wise. What like one of the big issues is you rarely find that there's not a queue of people behind you that have already booked up the bays that you would need to plug your second cable into. So that then lends itself, if the queue stays the way it is, then they push you into a totally, the only assumption is it's a totally different solution then. So that's the bit that we really need connection reform to kind of mop up a lot of these speculative projects. Like there's 5 gigawatt projects in the queue that don't even have land rights. You know what I mean? Like it's absolutely crazy. So again, once the queue's mopped up, it will open up more opportunities. Once we clear up a few bays, because there's the big issue at the minute of basically because all the bays are almost theoretically full. National Grid's just saying, oh, it's a new GSP, it's a new supply point. If you want to do anything or plug a second cable in.
Sorry, so do you think there'd be any opportunity for connection of a data center to a battery site, but effectively using the BESS as contingency? I don't know, perhaps by half in the tech, one either way.
So I'm not an expert on sort of the data center's needs for redundancy contingency, but some of our clients who obviously build the data center element, we're experts in getting the grid to the site. They are actively sort of looking at that and considering that. None of them have given me the green light at this point that a battery is suitable for contingency. So that's all. Sorry if I'm evading the question, but that's all I know.
Perfect, thank you. We've got time for one more question. Anyone? Okay, so maybe I can ask you one question to sort of wrap up. In terms of everything you've been talking about today, what is the one thing you've been spending the most time with your data center clients in the recent month?
Probably the due diligence piece in terms of actually testing, so we work with a lot of clients that are they're maybe purchasing sites to build out or they're actively developing. And that's probably the biggest thing is actually, they're maybe being sold a site by a developer who's saying, yeah, it's all par's good. 2028 is the contracted date. Is that actually achievable or viable? And it's sort of analysing those risks. So, we'll look at the DNO's network, we'll look at the work they have to do. Again, I used to program manage the transmission and large distribution connections. So I'm well versed in delivery risks. And so is the team. Our team is all sort of ex-transmission system planners and distribution planners. So it's flagging those risks, and a lot of time that you find that maybe the DNO actually has to buy a parcel of land next door to their substation. Nobody's even looked at who that landowner is yet. Can they buy it? Will they get planning for the substation extension? And all sorts of risks like that. So that's probably one of the main things at the minute. There's a lot of people looking for viable sites with power that they want to build this side of 2030. And that's the key, really.
Perfect. Thank you very much. So that it is the end of our session. So thank you very much, Brian. I think you're on stand 47.
Yeah, literally just right behind Laminar there. So if anybody wants to call over, we're there all day.
So if you've got any more questions for Brian, you can come and find him after. Thank you.
Thanks.